Now in this lesson we're looking at the gradient of a straight line. Now the gradient, or slope, of a line is a measure of how steep it is. And the gradient equals the rise over the run. The rise over the run. Now we consider this line here, and the second line there. If I asked you, are these going uphill or downhill, what would you say? Well, the first one's going downhill if we look from left to right, and that's the way we'll look at it, from left to right. So downhill, it has a negative gradient. So if it's going downhill, it has a negative gradient. The next line, from left to right, is going uphill. And if that's the case, it has a positive gradient. So let's look at this line. The gradient equals the rise over the run. So let's say we drew the vertical and horizontal parts in. There's our rise, and there is our run. Alright, so have a look at that diagram. The gradient is the rise over the run as a fraction. Let's consider an example here. If the rise was 3, the run was 4. It's going, what do we say? Uphill. So it has a positive gradient. We would say the gradient equals the rise over the run. The rise is 3 over the run, which in this case is 4. So we'd say in this case the gradient there is 3/4. Let's consider another diagram. With this time the rise is 2, the run is 5. From left to right it's going downhill, isn't it? So it will have a negative gradient. So the gradient equals the rise over the run equals negative. Okay, mark in whether it's a negative gradient firstly. The rise is 2, and we can see then that the run is 5, so it's over 5. Terrific. Okay, the example there shows a gradient of -2/5. Now let's look at some further examples. We're asked to find the gradient of the interval AB if A is the point 21 and B is the point 64. Well, let's just draw a quick sketch here. Now A is the point 21, so 2 across, 1 up, there's the point A. Now I'm deliberately not marking in anything else except the essential information. So there's the point A, 21. B is the point 64, so 6 across and 4 up, that's where the point B would be. Now we draw the interval AB, and we complete a right-angled triangle there. Now we can see then that this would be our rise, and it coincides with the distance between 4 and 1. So between 4 and 1 is a distance of 3, so the rise is 3. We're interested in the run, which, look at that, is the distance between 2 and 6, so the run is 4. So once we can identify that, it's fairly straightforward. Let's fade everything else out, and we can see the gradient equals the rise over the run. It's important though we identify, is it a positive or negative gradient? Well, it's going uphill, so it will be a positive gradient. The rise then is 3 over the run, which is 4. So our gradient there is 3/4. Our second example, we're asked to find the gradient of the interval DE if D is the point -3, 2, E is the point 5, -4. Well, again, we'll draw a diagram, just a quick sketch. D is the point -3, 2, so -3 across and 2 up, there's our point D. E is the point 5, -4, so 5 across, -4 down, that would be the point E. We draw our interval and then we complete a right-angled triangle. Now, the vertical distance. It is the distance between, if we look very carefully, 2 and -4. That distance is 6. The horizontal distance is between, on our axis, -3 and 5. That is a distance of 8. So now we just look at the triangle there, fade in the rest of the diagram, so just focusing on that triangle. The gradient equals the rise over the run. This time though going downhill, so it's a negative gradient. So we write negative before we forget. Now the rise is 6 The run is 8. So our fraction there is minus 6 on 8, and that of course will break down, and that breaks down to minus 3/4. Excellent. Well, that concludes our lesson. Just recall when we're trying to find the gradient there, just draw a quick sketch, just like we've seen in the previous two, quick sketches, and then just focus on the important information.